this is where I will look at strength. That is first based on universal indicator, by use of universal indicator. Then we'll also look at the effect of acids, the effect of electric current on acids, and that we can use to tell which given acid is stronger than the other by simply trying to focus so much on the electrical conductivity of acids. Strong acids are the ones that ionizes or dissociates completely. They're the ones that dissociate completely in water, simply to produce many hydrogen ion. Example, we have hydrochloric acid, which ionizes completely to give hydrogen ion and chloride ion. It is giving hydrogen direct, so therefore it is known as a strong acid. Another example, nitric 5 acid, which also ionizes to give hydrogen ion and nitrate ion. Sulfuric 6 acid, gives 2 hydrogen ions and a sulfate ion. We have seen all the three mentioned acids are strong acids because they are able to ionize completely to give hydrogen ion when in water, and they are giving many hydrogen ions. Now, weak acids dissociate partially to produce few hydrogen ions. Dissociate partially to produce few hydrogen ions. E.g., we have a good example is what we had talked about, that is methanoic acid, which dissociates to give hydrogen ion and ethanoate ion, and you can see that one can still dissociate further. What is formed as the second product can still dissociate further. That's why we are saying it is partial dissociation. We also have the well-known weak carbonic acid. Another example is weak carbonic acid that dissociates partially to give hydrogen ion and hydrogen carbonate ion, meaning the hydrogen carbonate ion formed can still dissociate further, and we are getting few hydrogen ions from there, therefore known as a weak acid. So, strong acids dissociate completely in aqueous solution, while weak acids dissociate partially, and we've seen that in our examples. To give hydrogen ions that are few in number, and they do so in aqueous solution. Now, if you now check on the conductivity of these acids, you realize that strong acids have higher electrical conductivity. Since they have many mobile ions. We have mentioned there that they ionize to give many hydrogen ions. So, the number of mobile ions that they give in solution are higher compared to the ones for weak acids. And that's why when hydrochloric acid is used, that is, when we test the conductivity of hydrochloric acid, then we use this acid as the electrolyte. It is clear that it causes a bigger deflection of the ammeter, since conductivity is dependent on the amount of ions present, and that is confirmed clearly by the fact that hydrochloric acid, which is a strong acid, has a high number of hydrogen ions, and that is why it has that higher electrical conductivity. Well, weak acids have lower electrical conductivity. Reason being that they have few number of mobile ions, and we have seen that from the fact that they have few hydrogen ions. So the number of mobile ions when in solution is lower than that in strong acids. And other examples of weak acids include methanoic acid and ethanedioic acid. Generally, all organic acids are weak acids because they ionize partially when in solution. Now, we have looked at keenly the ionization, and from that we have tried to check on the electrical conductivity. Let us now again try to relate this strength by looking at the effect on the universal indicator. Use of now universal indicator to tell the strength of acids and bases. To start with acids that we are still discussing, we know that acids have a pH value below 7. Acids have pH value below 7, where strong acids have lower pH value since they have high number of hydrogen ions. High number of hydrogen ions. And that's why you get that the pH value of an acid like hydrochloric acid is below 4. It has, pH is all about potential hydrogen. So, if we talk about the pH value, then it is clear mathematically that the higher the number of hydrogen ions, the lower the pH value. From the log concept, we are able to tell that the higher the number of hydrogen ions, the lower the pH value. And that's why strong acids have lower pH value and is normally between 0 and 4. Similarly, weak acids have higher pH value because of few number of hydrogen ions. So, the lower the number of hydrogen ions, the higher the pH value. And because of this few, their pH value ranges between 4.1 to 7. Simply 4 to 7. That is for weak acids such as methanoic acid. Now, NB. Please note that a weak acid does not necessarily mean dilute or strong acid. That does not necessarily mean dilute acid. Don't confuse the two. And strong acid does not mean concentrated acid. Remember, concentrated acid simply is determined by the number of moles in a given volume of that acid. That is how we tell concentration of the acid. It has nothing to do with the number of hydrogen ions. Now, as students, I want us to look at that story in a very civilized way. Let us say there are more hydrogen ions. The more hydrogen ions has nothing to do with number of moles of the acid in a given volume of that acid. But that number of hydrogen ions is all about the strength of that acid. And that's why we are saying when there are many hydrogen ions, then the acid is strong. And when there are higher moles of the acid in a given volume, then the acid is concentrated. I wanted to join those together so that we get the difference between a concentrated acid and a strong acid. Similarly, dilute acid and a weak acid. This therefore means that ethanoic acid, which is known to be a weak acid from what we have learned today, can be said to be concentrated. That is, when there are higher moles of the acid in a given volume. So it is said to be concentrated. Again, hydrochloric acid, that is well known to be a strong acid, can be said to be a dilute acid. That is, by adding more solvent to it, you are making it dilute. So it is not now concentrated, but still remains a strong acid because of many hydrogen ions. That is all about strength of acids.